So in this video about using dflat to create a simple lander program, I am going to now see how do we determine if a safe landing has been made. So if you've seen the previous videos, which if you haven't, you might want to, where I've got some obstacles and I can detect if the spacecraft has hit anything on the screen. Now, knowing that the spacecraft has hit something, what has it hit? Maybe it's actually hit the bottom of the screen on the right, which is where the safe zone is, or maybe it hasn't. So we have to determine that. So we'll use bounds checking, and also how fast was it moving when it hit? Because even if you've landed successfully in the right position, you still have to have the right velocity, so that it's deemed a safe landing. And we'll use the dflat conditional statements to do that, which is quite straightforward. If you notice here, when p is non-zero, this game loop completes, and it drops through to eventually to here, where XX and YY are the pixel positions of the spacecraft, and I'm saying you have to be at least 200 pixels across in the X direction, so really quite over, significantly over to the right hand side, and the Y direction, the Y coordinate, needs to be more than 187, and I've calculated that based on the highest row number is 199, the border is 4 deep, so that takes us from 199 to 195, and then the spaceship itself is 8 pixels high, and if we inclusively 8 pixels high, so if that's 195 minus 7, which will give us a 188, so it has to be touching or just over 187 is the Y coordinate. So that's the position. Then the velocity has to be bigger than minus 18 or equal to, and less than plus 18. So the horizontal velocity of the spacecraft has to be between minus 18 and 18 inclusive, and as well as that, the vertical velocity of the spacecraft has to be less than or equal to 20. So this is how an if command is constructed. I put brackets around the conditions because a condition such as XX greater than 200 evaluates to either 0 if it's true or minus 1 if it's not true. Now the ampersands here, these AND connectives, are actually bitwise AND connectives. So here I kind of combine the same the operation can be used for both Boolean conditionals and arithmetic conditionals, or logical conditionals rather, and of course if each condition evaluates to 0 or minus 1, and minus 1 is in binary all of the digits are 1, then that allows us to essentially construct this single if statement. And if the statement is evaluates to true, then the next statement will be executed, and it will just simply print you landed safely. Else, if that statement is false, then the else part will be executed if it exists, and here we print you destroyed the craft. And then the end if closes the if, so this allows dflat to have an if statement which can span several lines, which is again a feature that Oric Basic doesn't have. So let's now test this out. Make sure I've saved the program. I need to make sure I convert the program from a text file to a TAP file, and now let's load it. So I'll press F6 again to accelerate the load, and then let's start. See if I can actually make a landing. So, it's already decently fiddly, to be fair. So it's not bad fun already. Although this is not the end, you can see that it is already starting to feel like a game. Landed safely. So that's that. There are obviously lots of additional things I can do to this game. It's really not finished. I want to up the number of obstacles. I want to maybe change the position of the target where you need to land. And maybe I'll even do that with a kind of semi-landscape kind of effect, just like the original Lunar Lander. But what you can see already then is that this program, and if I actually in Notepad make this smaller, you'll see how few lines actually the program is. It's only 97 lines, and I'm going to try and squeeze it all into it's probably not sensible what I'm doing, but I'm just trying to show that it's really not a large program. There's the start and there's the end, and really this is the game loop. It's just 30 lines. So I will be doing more to it to add extra elements of interactivity and fun to it. But I hope you saw how dflat can be quite easy to program and create a simple but fun game with sound effects, real-time physics modeling, for want of a better term, using scaled integers to simulate fractional parts of a number. And really you can do quite a lot with this language. Despite some of the constraints, it's also quite speedy. Thank you for watching my video.